Hello, this is Professor Gruhn, and welcome back to CSC230 at Manchester Community College, online course on database applications with the web. Primarily, we're focusing on learning how to use MySQL. We are in Chapter 4 of Murach's book, MySQL. It's an excellent book, and we've really been enjoying it so far. We've already installed software. We've learned some basic overviews and understandings of database terminology, and we've focused on the select statement. And we've been focusing on the select statement with where clauses and order by, but we've always been focused here on one table. The very nature of a database and the design of a database would basically say we have more than one table. A relational database will say have multiple tables that are joined together by a common key. The biggest area that we see that in our AP database is where we have invoices and it will reference a vendor's table, or we might have invoices and it will reference a terms table. And what we need to do is be able to get the information from the terms table and the vendors table in our output. And the reason we do this is so we don't have to have redundant data in our initial table. So for instance, think about the invoices table. Would you want to have the company name, the company address, the company zip, the company state stored in columns for all of that, for every single invoice record or every single invoice line detail record? And no, you wouldn't. It's not an efficient use of space. It's not efficient use of the database. So that's why we have relational databases in the first place. In Chapter 4, we're going to focus on the join and the union. And commands are part of the select statement. And we'll see how they will allow us to join and union two tables together. Again, if you remember correctly, I told you about a way to cheat, or so to speak, and that is you can cut and paste from the SQL scripts that the book provides if you go out to their website. But if you're still learning and basically if you want to type, I think that's a better way, especially for beginners, to really get their hands dirty and mistype a few things and kind of learn how to make a few mistakes so you see what goes on. And at any time during these exercises, as we're going through the book, if you want to say, well, can I do this? Can I do that? What to do is try it. This is not heart surgery. This is not brain surgery. Nobody dies. Nobody gets hurt. All you have to do is issue the command that you think, well, can this work? Can that work? And maybe if we're not in an area that we've covered yet, you want to say, well, how do I do this? We've talked about using Google and type MySQL and how do I do this? And you'll probably find an answer because you're most likely not the first person to ask that question. So let's get a move on and start looking at Chapter 4. Okay, so in the book, I am on page 117, so please read 115 and 116. And that'll get you caught up to where I'm at. And what we're going to do is, let's take a look first at a couple of the tables individually. If we go select star from vendors, and then click, you can see here's all the data in the vendors file. There's a lot of information that we definitely don't want to store redundantly in other tables. And if we then take a look at select star from invoices and run that with the I, we can see the data here. Now take a look here in this column that the vendor ID is listed. Now this vendor ID in the invoices table, when we click the vendors and take a look at the vendors, will actually pull up and make available this information to us. So grabbing from the book on page 117, and I want to make this a little nicer. I want to be able to see this correctly. We're going to select the invoice number and the vendor name. The invoice number is in the invoice table and the vendor name is in the vendor table. And we do this by doing from the vendors table, do an inner join to the invoices table. And on the vendor's ID, then when the vendor's ID and the invoices vendor ID equal, make the information available and order by invoice number. Notice here the word vendors and the word invoices. These are referencing to the actual table names that we're doing the from and the join. And we're doing an inner join. And that's basically where an inner join is only going to display the data, the result, where this on statement is valid. Where this is true, display the data. Now if I issue this, you can see I have an invoice number and I have a vendor name, and we're ordering by the invoice number, and you can see that the invoice number is being sequential. And it's being sequential has a string because it's actually doing the first column. Notice there's 2s, and as I scroll down, there's 3s and then 4s. This invoice number is in fact not a number, because if you take a look, there are things like the letter C in there, there's a hyphen in there. This invoice number is actually being stored as a string. There's a slash in there. A lot of times in accounts payable system, you might have an invoice ID, which is really a number, but the invoice number might be some sort of string because different companies have ways that they want to display the data. Having to write the word vendors and having to write the word invoices really can be kind of a pain. And what we want to be able to do is we can use this thing called aliasing. And aliasing allows us to make little short names. So if I put a letter V there, and if I put a letter I here, those are my aliases for those file names, and then I can put a V there and then an I there. The invoice number is actually coming from the invoice table, and the vendor name is coming from the vendor table. And if I run, I happen to run everything there. If I run this now, you'll see that the same statement is working, but I'm kind of saving some letters, and I'm using this thing called aliasing. On page 119, under figure 2, there's a few versions of that, of aliasing, available to us. I'll execute this, and you'll see that from vendors, alias with V, join invoices, alias with I, on the vendor ID from the V alias, and that equals. And what's interesting here is these names here in the select statement. What you'll notice that they don't have an alias in front of it. The reason is, the rule basically is, if two tables, or however many tables, have a unique name, then what will happen is it will be smart enough to know where that column is. But if there was a vendor name table field, a vendor name field in both tables, you would have to prefix it with the proper alias. Notice on this too that there's a calculated field being created called where it's invoice total minus the payment total minus the credit total as balance due. That's this column right here. That's being created, and a where clause is being added to this join, where invoice total minus payment total minus credit total is greater than 0. So only give me those invoices where I basically have a balance of greater than 0. and we have an order by clause here that's saying order by the due date, because basically I want to know who owes me the latest, who are the people who are the most past due in that statement. Another example of the using aliases with a join, the book gives us on page 119. Boom, boom, boom. We're joining, and I'm going to take a look here. So here you can see, select these fields from the invoices, joining the invoice lines table with an alias of called line items. Now the invoices in the ID is equal to the line items invoice ID. That's still, and where account number equals 540. So I can run this, and here's this is a true condition, and it's giving us all that information. And maybe I want to be sure. Let's add account number to that. And here you can see that account number is in fact equal to 540. Quite honestly, I probably wouldn't use line items all that much going out. I would use something like LI, and I would go I for invoices. So that way I would probably end up saying I here, and then LI here. And this will still work. And it's a little cleaner that way. Sometimes I've seen people actually take this and put that many spaces out to it. That's kind of getting to personal preferences. You develop your own style of how you lay things out for such. Now, if you remember correctly, we've talked about having on your computer multiple instances of a data server, of MySQL. Within that, you can have databases on that. Now, we've been focusing so far on the AP database on our MySQL server. In the OM database, if I open that up, and if I look at there, I have tables called customers, items, order details, and orders. Also, what's interesting, just a side note, notice down at the bottom here that under customers, I actually get a description here. And if I was to go describe customers, oh, we've been using the AP, so sorry about that. I need to go use OM. And then I can go describe customers. And I can see all of the data there in or the description of the column names that are in the customers table in the OM database. I'm going to go and let's go select. Remember, I'm in the OM database. Select star from customers. Let's run that. And you can see all this customer information that's available. What I want to do now is I want to go back and I want to use the AP database. I want to get back into that. So now I'm using AP data that if I was to go select star from customers and run that, I'm actually getting an error here because the table AP customers doesn't exist. So I'm in the AP database, but I have a situation in which I want to reference the customers table. I can do that with a join, and I need to be explicit about what database it's in, as long as it's on my instance. It's in my instance of MySQL. So let's take a look, and we're on page 121 is the example there. Let's make this a little prettier real quick. Remember that if a field name, if a column name is not used by other tables, then the database will be smart enough to know exactly what column you're interested in getting the information from. So read this. We're going to select the vendor name, the customer last name, customer's first name, the vendor state, but we're going to label it as state, and we're going to select the vendor city and label it as city from the vendors table, and we're giving it an alias of V, and we're going to join the customers table that's living in the OM database and alias that as C. So on when the vendor zip code is equal to the customer zip code. Let's see what happens. And what we're getting now is the vendor information and customer information and the state and city from the vendor table. So this is pretty cool that what we can know now is vendors and customers, and they're being joined together at this point by a common zip code. I don't know how often you do something like that. Typically you do it on a primary key like an ID or something like this. But here what we are getting is a sense of all of the customers and all of the vendors that are together. Okay, we're going to flip databases, and there is this database over in our object browser called EX. And what we want to do is we want to use the EX database. Okay, so now we have the EX database available to us. And we're going to take a look. There's a employees table and a customer table. So if I go select star from employees and run that, you can see I'm getting employee information. I have an employee ID, a department number, and a manager ID. And then if I go select star from customers, if I run that, I have a customer ID and some customer information and customer zip. Now what's interesting here is we're going to, the customer ID and the employee ID are there's some duplicate customer's ID. In real life, I don't think we would do this one at all. I don't like this example that the book is giving us, but we're joining the customers and the employee table together. And what you can see here is we're getting the customer first name and last name, and we're joining it from the employees. I think what I'd also be interested in doing is grabbing the last name and call that emp last name, just to kind of prove how lame this example is. And basically what we're getting is where the customer first name equals the employee first name, and the customer last name equals the customer last name. So we're getting Tom Hardy. who happens to live in both databases here. I don't think we'd really do that a lot, but the point is that what we're showing is a compound join, where we're going from the customers table and joining the employees table. I want you to join the first name and the first name together, and the customer last name and the employee last name together. So what you can do when you're joining something together is, by having a compound join, you can have more than one condition to pull the two records together. So if I was to actually say, comment that out, the last name out, and then run this, we're still getting just one person with the first name. But let's comment out the first name and see what happens. We probably need the word on there, and then run that, and we still get one. So we only have that condition is true either way. The book is kind of jumping around here now on pages 124 and 125. We've got to now go back and use the AP database. And what we're going to do here is a self-join, where we're actually going to join to ourselves. Again, I feel like this example is falls in the area of lame. I would think they actually have a better example in the EX database for the employees. But let's run this example first, and then we'll kind of ad hoc the other example. And what we have here is the vendor name, vendor city, vendor state, and basically those people who are sharing a vendor state, and we're basically joining vendors, calling it V1, and vendors calling it V2, and saying who is sharing the same states with cities and states that I have. What vendors have the same city and states? I think this is a really lame example, and what I want to do is, I haven't practiced this, but we're going to kind of pull this off real quick. Let's go back to the EX database, and let's use that. So we're using the EX database. In the EX database, there is an employees table. Now this employees table is actually pretty well thought out. So if I go select star from employees, and if I run that, I'm getting all the employees. Notice that the employee ID and the employee has an ID, but there's also a manager ID. So what that's telling us is that and managers are all employees. So who is somebody's manager? That's kind of the goal here. And what we're going to do is build this statement. I'm going to pause for a minute, build the statement, and test it, and then I'll show you what I do. Okay, hopefully I've put together an example of a self-join that makes a little more sense. So here, we're going to select some columns, I'll go over those in a minute, from the employees table as E1 and join the employees table as E2. So I'm basically joining the employees table to itself. Now what happens is that the manager ID is actually the ID of another employee. So for instance, I want the employee ID from E1, the first name and the last name, and the manager ID of the employees. But I want to display the name of that employee's manager. So here I'm going to display their manager ID, but I'm going to concatenate the E2, the first name and the last name, which is actually coming from the employee ID has the manager. And then, so I'm doing the join here, employees as E1, join employees as E2, where the manager ID equals the employee ID, ordering by the manager. So now you can see manager ID 1, manager ID 2, 4, 8, and 9. These are the names manager ID number 1 is actually Cindy Smith, Elmer Jones, number 4, number 8. These are the managers of these employees. Now, managers that don't have employees that don't have managers don't have IDs, so there is no join happening. So all we're getting at this point are the joins from the from those employees that actually have managers. Okay, we're now up on page 126 and 127. We have to now flip our databases to use the AP database. We're moving back to that. So now we're using the AP database. And here the example is actually showing us joining 4 tables together. The vendors table is being joined to the invoices table, is being joined to the invoice line items table, is being joined to the general ledger accounts table. And then when we run this, we can get the vendor name, the invoice date, the line item amount, and what account that it's going to be applied to in our general ledger bookkeeping system. So take a look carefully, read this over a little bit, and you'll see how you can take many different tables and join them together. So using the join on syntax is syntax that I don't see many people at Yale where I work using. That what we actually do most of the time is use what is known as explicit joins. I think it's a lot easier to read and it's a lot easier to understand. And on page 128 and 129, we see examples of that. And I had already done an explicit join in an earlier tape. But take a look here. I think this reads a lot easier. Is that select the invoice number and the vendor name. So we're getting the invoice number from the invoice table, the vendor name from the vendor table, and we're saying from these 2 tables where the vendor ID is equal to the invoice ID. And then when we run this, we get the correct information. I personally, and I think in most cases, you will see the where clause being used more than the join on being used. Also, the other example the book gives, and here there is multiple tables being used. We have the vendors table, the invoices table, the invoices line items table, and the general ledger table being used. And we're joining multiple tables and getting information from the vendor, the invoice date, the line item amount, and ultimately the chart of accounts, the account description. So using explicit joins with a where clause is probably the preferred method. So now we're on page 130 and 131. So far we've been doing inner joins. Now with either using the word left or right, we can do this thing called an outer join. An inner join basically returns all the results that are true. So on your where clause or on your on clause where you're saying this is equal to this, you will only get the records where that case is true. But in this scenario here, it's saying, give me everything, and I don't care if there's if it's true. I want to see, in this case, a listing of all my vendors, and this kind of tells me if they have invoices or not. And what happens if I turn the word left to right and run it? Now I'm getting all sorts of invoices, and I'm actually going to get wrong data at this point because of the way that join works. So you better be really careful with your outer joins that you're actually getting true information on that. But here I want to say, I want all of my vendors and I want to join them to invoices, knowing that invoices do in fact exist. The next few pages give some examples of more outer join usages. So go ahead and read those pages and do those examples, and that will get us up to page 136 and 137, where we're going to be joining tables using using the keyword using. And what this does is it allows us to make the statement a little simpler when we actually have a common ID. And so here we're actually going to join the invoices using the vendor ID. And so the vendor ID will pull us that. So it's another way of doing the same thing. And then here we'll do boom, 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 department name using, what's going on here with department name? Okay, once again, the book's jumping around on us. We need to go back, and now we need to use the EX database, and then we can execute this join where we're joining the departments and the employees. And does that actually have, and the projects table together based upon the department number and the employee ID. So read pages 136, 137, and that'll give you more detail on that. Again, this is another way of joining tables together. Quite honestly, in all of the code that I have seen over the many years, we traditionally use explicit, where this table equals this table. The explicit joins the using and the naturals. I don't see them used a lot. And somebody might see this video on YouTube and say, this guy's full of junk. Well, that's fine. I'm just saying from my experience, I find that the where and the explicit ID seem to be a lot easier to read and a lot easier to understand. Okay, here's another not commonly used way of joining tables, and that is with a natural join. A natural join basically is saying, be smart enough to kind of figure out what it is you want to join on. I personally think this is really, really dangerous, and you better be sure you know what you're doing. In this case, the invoice number is being joined to the vendor, and the vendor name is being joined, natural join from the vendors to the invoices. It happens to work, but it's not explicit. And I mean, I'm a little more anal, and I want to know exactly what is joining to where. In the EX database, we use this, and we run this as well. We're getting appropriate workings, but then the problem becomes that do we really know what that natural join is really tying together? Take a look and read in more detail 138 and 139. Honestly, it's not used a lot from my experience. There may be situations where you need this cross join to happen. In most cases, cross joins happen by mistake, and that by a cross join, it can happen with where clauses when you do explicit joins, and if you don't do the correct inner or outer join, it can happen. But here what happens is we end up with getting a list of everything in both tables. And we end up with a lot of different rows and records and a lot of redundancy. And for every record that is in the department table as well as the employee table, we're going to get a result from that. Okay, so now this next statement, and it's shown on page 142, 143, 144, 145, 146, and 147. This happens a lot where you will union two select statements to come up with a result set. So what happens is we need to know the results of one statement first before we can then, from the results from that, then join and union together the results from another. So using the EX database, we have, if I go select star from active invoices, and if we run that, here's all the information for our active invoices. And we have another table called paid invoices. Here's all the data from the paid invoices. Well, a paid invoice and an active invoices, we need to do some calculations to determine what data is left to be paid. So if I pull on page 143, there's an example of a union happening. And if we run this, we see that what we're getting is an invoice total, an invoice number, and an invoice due date. But what I believe, hang on a second. Okay, I'm back. So the active invoices table and the paid invoice tables are exactly the same structure. And what we want to do is basically we want to say, here's all the invoices that have been paid, and here's all the invoices that are active. And we basically want to put them together into one select statement. So what we're doing is we're saying, here's the ones that are coming from the paid table, and here's the ones that are coming from the invoice table, where this invoice date is greater than or equal to June 1st, 2011. So what we can see is which ones have been paid and which ones are that are outstanding from this date forward. The next couple of pages basically continue on with a couple of variations of the union statement. And instead of me stuttering and reading through them, take your time, do each example, and read the business case as to how these unions are happening and why they're happening. So that'll get you through. That's basically page 146, 147, and 148. And then the examples are on 148, 149, and 150. There's 7 exercises to do. There's a sheet to download. Give me the screenshots for each of the examples. Maybe you might need more than one screenshot, and that's fine. But basically, it's your goal to do the exercise and show to me that you've done it and that you understand it. Feel free also in the homework assignments to write any comments, any notes, any observations, and any troubles that you might have had along the way as well. That's a good way to communicate to me what it is that you're doing and been enjoying. And also, if you've come up with something cool and you want to add that to the end of a homework statement, absolutely, please do a cut and paste and display that as well. So hopefully this quick go through in chapter 4 has been helpful. We cut it down to about 38 minutes, so hopefully this will help you get through it pretty quickly. Very good. Have a great day.